Hello, everyone. This is lecture 6 of Advanced Drilling Engineering 451545. I uploaded I made an update of the slide deck last night. Basically, it was, if you see module 1, it says updated January 30th. In the early mornings of today, I did it. Basically, there was one slide that I had the animation wrong. I think it was slide 28. I fixed that. That was the only issue. Then some things I moved them around to make space for the camera on the top right. So this one now it's, oh, I guess, okay. Where is slide 28? I didn't fix it. I will fix it again and update it, I guess. But I added one more slide here, slide 20, and it's basically something that came to my mind afterwards, and I read it somewhere, but it was like, because we talked about the derrick and stuff, and I forgot to tell you that the derrick got its name after Thomas Derrick, who was a British executioner in the 17th century. So he built something that looked like a derrick for his job. It was like, I think he was convicted of some terrible crime with some other friends of his. And one of the dukes in England, they basically told him, we will pardon you if you become the executioner, because nobody wanted to be an executioner those days, because, you know, the families of the people who die are chasing you. So he became an executioner, and he did a lot of executions. And to assist his job, he built something that looked like a derrick. That's why the name derrick is used today, even today, for oil wells. And he ended up even executing the guy who gave him a pardon eventually. He was, anyway, I guess he did a lot of executions, but that's how the derrick got its name. And I guess I need to fix slide 28. I saved it without fixing the animation. And I think where we stayed last time would be now slide 40. It was 39. We finished talking about the circulating system. We talked about the mud properties. And now we are moving slowly to an overview of the rotating system. And we said there are two types of systems that are used in rigs to provide rotation. One is the Kelly rig, or the rotary table, which is the traditional kind. This is what Anthony Lucas used in 1901 in Beaumont, Texas, which is basically you have a rig, the rig floor has a rotating table, and you put your drill string there, and it rotates, and from the table you get motion into the drill string. And we said the drill string is composed of the
Composed of the paper, the button hole assembly, and then the base.
yeah. Bottom hole assembly is one thing, which can be a lot of stuff, as you know, like it can be a logging while drilling tool, it can be a rotary steerable system, it can be drill collars, which are added to basically drill pipe that is very heavy and thicker, and it's added there, and it's placed there to add weight. It's some stuff that starts with J. What's the name? For I forget the name now, but there are some things that are like explosives that if your drill string gets stuck to the wall, you set them up and they basically explode, and they basically shake the drill string and they try to break it loose. I forget the name now. Starts with a J. I will come back to it. But there is a lot of basically components. The BHA is a very expensive part of your drill string. And generally, if you lose it, you have a lot of stuff to pay for. Like the logging while drilling tool is something like $1 million. and you lease it from the company. And if you don't give it back because you lost it downhole, you have to pay for it. It happened in a rig that I was at that they got stuck and then they couldn't get unstuck, and they had to cut the drill string and recover what they could. And obviously they lost the BHA and they had to cement it in place and then go sidetrack around it. And they had to pay something like 900,000 to the LWD company because they basically lost it downhole. And it wasn't even insured. If it was insured, it would have been like 700,000, still a lot of money. But yeah, big part of the drill string. Now the rotary table main components is, let's see them in this picture. You have the swivel, and then everything underneath the swivel is rotating. But the swivel is not providing the motion. The rotary table here is what provides the motion. And it's obviously electrically driven. And the first joint of because you know the drill string is cylindrical, right? It's very hard to rotate something cylindrical. How do you apply torque to something cylindrical? So we have a very special joint at the very top of the drill string, and it's always that joint. It's called the Kelly. And the Kelly is either square or hexagonal. Okay? It's always either square or hexagonal, and it's basically shaped this way to allow rotation, because this is what you are actually rotating. And everything underneath it is pretty much cylindrical. The swivel hangs from the drilling hook of the traveling block via a large bail. The bail is this hanger part. Let me just highlight it. And I will use yellow because most of the times it's yellow. This thing is the bail where the hook grabs. And the hook is connected to the traveling block. And then on top of it, you have the crown block, etc., etc. So this is the Kelly, which is square or hexagonal. I have heard about octagonal Kellys. I never saw one. And this is the rotary table, which is providing the rotation. A Kelly is a 40 or 54 feet long square or hexagonal shaped pipe that rotates the drill string connected below it. It fits in a square or hexagonal opening called the Kelly bushing, which itself fits into the rotary table's master bushing. So this table is what, sorry, let me make it. I want to highlight it. This is actually the turntable or the rotary table, same thing, is what moves. Okay, inside it you put the master bushing, inside it is the Kelly drive bushing, inside is a Kelly saver sub. Is basically when you hear sub, think that you are going from one size to another size. It's basically, it's an accessory. And then in it goes the Kelly. Okay, and let me see if I can very quickly find a better picture online to show you. I go Google and I go Kelly bushing oil rig and I see the pictures. Okay, you can understand now from this that it's not cylindrical, right? It's not circular cross section. It's
That is
hexagonal or square. Let me see very quickly. It's the same thing. But yeah, basically the whole rotary table this is turning on the rig floor, and it turns everything that is in it with it. So that was the technology then. And this is an old style. And you understand because no. We said it's 40 or 54 feet. It's not a lot. So what you can, where is it? What you can do with it, yeah, go ahead.
Can you show it at the picture that you took from the field trip, or is
That was the top drive. It wasn't a Kelly. It
Yeah.
wasn't a Kelly rig.
okay.
There is no Kelly rig in Williston right now, as far as I know. Or if there is, might be just one. It's very, very old technology.
Yeah, the modern Bangladesh.
Actually, if you are in the Permian Basin and you drive towards Pego City, on your right, entering the town, there is a yard with old rig parts. And you may find there some old rigs that are small ones, and they are rotary table rigs. They are. But you see, this is 40 to 54 feet long. So you understand that the most you can put down hole is obviously a joint of 30 feet, 31 feet. But when you are removing from the hole, when you are tripping out of the hole, again, you can only take a 30 feet long 30 feet long joint, because if you try to pull out two joints, it's going to become 60. It would be bigger than how high you can go. Okay, so this leads to a lot of non-productive time, which is basically the rig is not making hole, because when you are tripping out of the hole, you are tripping one joint at a time, and when you are running in the hole, again, one joint at a time, you know? So this is a little bit inefficient. So people started experimenting about making a taller derrick and providing rotation through the swivel. So let's make the swivel, replace the swivel with something that actually provides the motion itself. We call that the top drive. So instead of a swivel, you have this. And you see the traveling block with the red. Let me see. This is the traveling block. This is the top drive. The crown block is somewhere here. This here that you see, you know what that is? That's the monkey board where the derrickman is standing. Remember I told you it's a little bit dangerous and you have to wear a harness. You understand that there is nowhere, nothing on the side to put your hand if the wind is pushing you. Yeah.
And that's the safety wire, the wire for the
This one?
Yeah.
Probably, actually. Yeah, that's the Geronimo line, probably. And I think you understand that this is.
Yeah.
Actually, these are just wires. This is where the mat.
I thought that was the mat.
Yeah. No, these are wires. It looks like a rotary hose, but it's the wires. These are the elevators we are going to talk about. The top drive is a very, very powerful piece of equipment in the rig. A lot of technology goes to it. It does a lot of stuff for you that the traditional rig is doing. It's they try to have the top drive do as much as we can do, so that you don't have things happening on the floor, because that's where all the accidents happen. You don't want high pressure equipment on the rig floor as much as you can. I mean, it's not impossible. It is impossible to have no high pressure equipment, but you don't want this stuff near humans, you know? On modern large rigs, the swivel and rotary table arrangement are replaced with a powered assembly called the top drive. The top drive hangs from the bottom of the traveling block and incorporates a heavy powered motor where the drill string is directly connected to. No need for Kelly or Kelly bushing. And obviously, this derrick is 100 feet tall. So you can move 90 feet up and down the top drive, 95 feet or something. That means you can, when you are pulling out of the well, you are basically pulling 3 joints at the same time. So you are 2.5 times as fast, you know, more efficient. So
when you are running all, you can only do one at a time.
no, when you are drilling, you are doing one at a time, regardless of what rig you are. That's how it is. But when you are running in the hole, it's like the hole is already drilled and you are pulling a pipe back into the hole. You can do 3 at a time with the top drive. And with
But during drilling, you can only add one.
yeah, you go one at a time. When you are actually making hole, yeah, regardless of what rig you are.
But at what point are you can do 3 at a go?
3 drilling 3 at the same time.
No, you said drilling, you are doing
Always
only
one, yeah.
But at what point that you can do the 3?
When you are running when you are running in the hole or when you are pulling out of the hole. When you are tripping in or tripping out.
Or when you are removing?
Yeah, and when you are pulling back in. You remove from the hole, you replace the bit, and then you want to go back in and start drilling. When you go back in, you go 3 at a time with this.
Okay.
It actually,
what do you mean by 3 at a time?
3 pipes.
like stands, a stand has 3.
Yeah.
A joint is only 1.
Yeah.
And also, when you are drilling with the top drive, you drill faster. You can apply more weight on the bit, and it's more powerful. It's more powerful. It's modern stuff versus Kelly rig is all technology. It's all technology. There are rigs in Texas, small rigs, Kelly rigs from 1969 still operating. There is a company I know, a guy. Actually, the guy that was remember that movie we watched? And there is a guy who said that historian. The one that said that this guy, his name is Mike Shellman, and he's I don't know. I think he was gonna sell the company to somebody my age that was working for him, but he has a small company in where is the place next to Austin? That not San. Is it San Marcos? 1 hour from Austin. Where we were going to float the river. Yeah, I think it's San Marcos. But yeah, he has the rigs that he leases are very old. And he drills like he goes to depleted areas and tries to get some old pockets of oil and gas, you know. That guy is, but I think he's retired, or he said he was gonna retire. He has some very extreme views, and I think he got kicked out of some organizations and stuff because he was expressing those weird views that he had about oil exports. He always thought that shale is basically cannot be profitable for anyone, which is ridiculous. There is people who made a lot of money out of shale, you know. Anyway. Advantages of top drive rigs. They are safer. No need to move out of the way when tripping out of the hole. And you know, these people that work there on the rig floor, they do the same job for 12 hours a day, 12 and a half hours a day. It's a terrible life. And when you do the same job for a lot of time, it's like you become complacent, you know? You know, it's like putting your head into a crocodile's mouth. You do it 10 times, nothing happens. At some point, it's gonna close. You know, and they all say the same thing when something happens and they lose their finger or something. They say it happens, and then you feel the pain. So it happens. You don't notice the damage that is happening, and then you realize what happened. You know, so you become complacent when you are subjected to a danger for a lot of time, and then so you want to make it safer. You don't want them to be near this kind of stuff like spinning chains. A lot of people lost their fingers because back in the day they used to make the connection of the joints with a spinning chain. You have to throw a chain and basically throw it on the two joints that you try to join, and then the driller would basically spin it back. And this is how the connection is made. And if you have your finger or something near the chain, when the driller presses the button to spin it back, I mean, this is gonna pull your hand with it, you know? And this is very dangerous. And a lot of people lost their fingers in the spinning chain. And that's why they make them, the gloves, they make them in bright color.
But you make money.
One day in your life.
Yeah, I mean, it's better to have on your fingers. But what was happening? They make the gloves very bright color, like they make them bright green or bright yellow, so that it gives you the impression where they are, where you have them. Like it said, "Oh, my hand is here," because I see it's a bright color. You know, it gives you more perception-wise. This is what they told us in Halliburton. Okay, it's faster. Kelly is drilled down. It means that you reach the bottom of that. The whole Kelly was drilled, was 40 to 54 feet. So you need to basically shift it up, take it out, put the new joint in, make the connection, and then start drilling again. Now, you see only a single joint can be added each time. Rigs with the top drive can drill a stand of 2 to 3 drill pipes. This is not always the case. Most of the time they drill just one joint, but I have even seen a rig, experimental rig, that was made 120 feet tall or something to drill 4 at the same time, which is crazy. I think it didn't work out. The wind was very strong. Something like it was something. It wasn't working. Assist with directional drilling, fewer connections, so less time needed to reorient the drill string after a connection. So when you do directional drilling, positioning is very sensitive. So you move the drill string a little bit, you might lose the angle that you want to be. Every time you make a connection, you are like shaking things, you know? Not only that, you also can get the gas inside your mud system. A lot of things happen during a connection that you don't want. Okay? Higher efficiency, you can rotate while pulling out of the hole, is called back reaming. This is actually very useful these days because they drill down and then they go directional like miles. And generally, it's not a straight hole, it's a hole that goes like this. And when you finish drilling, you're gonna pull out of the hole and you're gonna run casing. The casing is thick. It's gonna be hard to run in a hole that goes like this. So you want to make it sure it's the best, as uniform as you can get it to be. So what they do is that they back out slowly and they rotate the bit as they back out. And you have behind the bit some things that are like wings, and they're called reamers. And they're basically, I will show you pictures later of a reamer, and they are basically rotating as you move back. So it basically cleans up the side of the hole and makes them smoother. And it's a slower process than just pulling out of the hole, but it helps when you go back in not to get stuck. Because getting stuck is the worst problem that can happen, worst everyday problem that can happen during drilling is differential sticking, basically. I was in a rig in Midland that the bit was destroyed, but we were very close to the end, so that they didn't want to pull out of the hole and replace the bit because they knew if they had to pull out of the hole, they had to back ream the whole way. So the operator was how to say, very tight with the money, and he didn't want to back rim. He didn't want to trip out. We were drilling with like 5 feet an hour, which is like very slow, extremely slow. And they called somebody from his company to come over and convince him to change the beat. Anyway, disadvantages of top drive rigs. More expensive, okay, I think you understand that. They are newer, more modern compared to the smaller Kelly rigs. And generally you will find them in like the more hostile environments. Like you find them in Williston, that is very cold. It's not the most friendly environment. Whereas in Texas, you still find some Kelly rigs, you know? But I guess Kelly rigs will eventually, vanish. They will be at museums and stuff. Manufacturers try to develop small portable top drive systems for use in small rigs. And they have a bigger footprint. It is a bigger structure, you know, it's a bigger structure. Requires a taller derrick or mast.
But,
Yeah.
but the footprint issue it's in the air. It's not down. That's
Yeah,
we are
but I
concerned
mean,
about.
still, it also takes more area. It's a bigger rig. It's a bigger rig.
Yeah,
It's a bigger rig.
but is it not hanging in the air?
Well, it's also taller and
Okay.
wider.
Yeah.
Yeah, it's a bigger structure. It's a bigger structure. Also, you need more, when we say bigger structure, you need more containers to transport it. And sometimes you need to move it
Yeah.
to go from one hole to another. We call it walking the rig. It takes like 12 hours to move like, I don't know, 12 feet or something, 10 feet from, because, we are drilling a pad. It's a bigger, more complicated processes, etc., etc. By the way, did I tell you the difference between a derrick and a mast? I don't remember.
I actually don't remember.
No, the what?
Okay. Did I tell you the difference between a derrick and a mast?
Maybe
No.
I know, I say.
Yeah.
The mast, like you picked it from the ground as it is and it goes up, but the derrick you build it.
No, derrick is a permanent structure. Mast is a temporary, like you build it. Or you can flip it.
Like key energy, the one that we've seen in.
No, that was a workover rig.
Uh-huh.
That was a workover rig.
Yeah.
It's a track mounted rig. They might be calling it a derrick. Well, they might be calling it a derrick, but I think they call it a mast, to be honest. But it's different. It's like it's a rig on a car for a temporary job, like a workover job. So
For the
The mast is
for the
temporary?
max, so that
The-
one.
yeah,
Okay, so for the max is it meant for maybe work over or anything for temporary?
no, mast in general is you can find drilling rigs with a mast, but it's a temporary structure. It's like you raise it or you build it, whereas the derrick is like fixed on fixed on the rig floor or something.
So what's the
So-
use of the mast?
Uh-huh.
The same thing, same thing.
So can a rig have two of them at the same time?
No, you will need to replace it. You will need, if something happens to your derrick, you are going to replace the part that is broken. It's a strong derrick, can hold more weight, can apply more weight, can hoist more weight. It's a permanent structure. Whereas the mast is like the capacity is lower, but it's probably smaller. It has other advantages, and obviously you can transport it easier.
So mast is more for workovers.
Well, I mean, workover rigs is a different sort of rig category. But yeah, I mean, depends on what kind of rigs. In general, the rigs for the workovers, you go there and you already have a well, you want to pull something out. It's generally you are pulling the sucker rods for the artificial lift.
Mhm.
And it's a track mounted, the ones that they have. I saw some in California. I think they were all track mounted that they have.
So what we saw at the Key Energy when we went for the field trip.
That was a track mounted.
Oh, okay. For
Yeah.
work over airports.
Yeah. You pull out of you want to replace the pump, the downhole pump, for artificial lift system, and you bring them to do the job for you.
But sometimes they close it with the cement and you need to drill over it.
Uh-huh.
So there would be a small drill in, like a small derrick or small mast.
Yeah, I think you're gonna do that with coil tubing. If you plug
With
in
drilling?
you plug in a bundle, and then you're gonna go in to drill the plug.
Yes.
Yeah, you're gonna mill it most likely with the coil tubing. It's probably gonna be easier to do it this way. It's faster.
You can drill with a coil tubing?
Yeah. You put a little bit of a bit, a small bit, at it's called a mill, and you go through. You know when we do plug and perf, and we have to drill those plugs.
Mm.
If they do it with coil tubing,
Okay.
yeah, you go there, run it down. It's quicker this way, and you are not really drilling big sections of rock. You are drilling like small plugs that are made intentional to be able to get drilled out. So you make as much of it possible with plastic, cement, and this stuff that you can drill through very easily. Yeah, one of the advantages of coil tubing is coil tubing drilling is very, very quick and simple. So the bit now, the bit is at the end of the drill string. It is a tool that bores the rock, transforming it into fragments called cuttings, which are then transported to the surface by the drilling fluid. The choice of type of bit depends on the hardness, abrasiveness, and drillability of the rock formation. Several bit types, but two main categories. The roller cone bit, which has rollers that are moving as you are rotating it. Do you guys know who invented the roller cone bit? 1909.
Yeah, I remember.
Howard
I've heard
Hughes.
about it before.
Howard Hughes
From Baker Hughes?
Senior.
Howard Hughes.
From Baker Hughes?
Yeah,
1905.
1909. 1909. And they did, what did they do? They had I saw the pattern, I read the pattern. Basically what they did was they went to the rig and they got the crew to leave. And they put the bit to the drill string and then they moved it down a little bit and they told the crew to come back and run it completely down hole and they tested it. And this is how they knew that it was working or not. So when they made the roller cone bit, they started the business of leasing out drill bits. So you lease it out to the company and they bring it back to you after they are done. And they made a lot of money because it was a time when everybody was drilling, and not everybody was finding oil, but everybody was using bits to find oil, right? To drill. And they made a lot of money. And there was a period I don't remember, was it? I want to say early 1930s or late 1920s, or maybe early 1920s, I don't know. But
We were young at the time. I remember.
yeah, I don't remember, but he was it was like he was the only one from the oil industry that had money because of that. So a lot of people made money in the 1930s in the oil business because the Great Depression hit the US and the corporations were on their knees, you know? It was like, so they couldn't compete and independents were coming up, like doing well. So the 1930s was very bad for the business corporation, the big corporations, but there were some people in Texas who made a lot of money because they had no competition from big boys, basically. But anyway, Howard Hughes Sr. died fairly early, and he left his business to his son, and his son is actually Howard Hughes Jr., was very famous. If you watch the movie Aviator from 2004,
DiCaprio?
yeah, the guy DiCaprio was playing was Howard Hughes Jr. And he was he was a very smart kid. He grew up in Houston, but he liked aeroplanes and he liked movies and he liked women. So he moved out of Houston, and he was still the director of his dad's company. And he went to Hollywood and he made some movies, and then he was building aeroplanes, and he had a lot of money. And at some point, he was the richest guy in the world, and he had OCD. And towards the end of his life, he had a terrible ending. He died. He died on air. Actually, they were transporting him from Mexico over to Houston for treatment. And yeah, I think the last years of his life, he spent them locked into a hotel room or something. And it was very sad, I guess. But he made the Howard Hughes Foundation, which gives a lot of scholarships to people, even foreign students, actually. So he did help a lot. And the GPS, he did a lot of technology himself that he basically invented a lot of technology that brought them he helped a lot. I think he went to California Institute of Technology, but he dropped out. And for some time he owned, you know, the airline TWA, the airliner TWA.
I don't think they're common.
They are no longer existing.
Okay, no wonder.
But I remember them when I was young. The rear wing was red and had TWA with white color, the logo. It belonged to him. It belonged to
It's
him.
not TUI, right? Not TUI.
No, TWA. Was. Yeah, it belonged to him. And what else did he do that was? Something else he did. Oh, yeah. In 1933, the same company invented the tricone bead, which is what we see here. The bead that his dad invented was 2 cones. This one is a 3-cone one. And it was like 1933, and he was the director of the company, but he wasn't involved in the invention. The tricone bead, and we still use it even today. Yeah, what did he do? That was anyway. The other kind is the fixed cutter bead or the drag bead. And this is again a more modern kind of bead, and is used in different kind of rocks. Like if you are drilling softer rock, it might be better to use this one, but not all kind of softer rock. Some rocks are better with a roller cone bead. Some rocks are drilled better with a drag bead. Now, one kind of drag bead is the PDC bead, polycrystalline diamond compact bead. Those beads are like $50,000 each. I have a picture from the rig that it's my car parked next to a box with a bead in it, and very, very expensive. And generally, what they try to do is that they try to replace the diamonds after it's been used, and they are basically trying to reuse it. The diamonds are welded on the bit, and Baker Hughes actually has big, big, big research center, big R&D program on bit design. I mean, historically, because it started as a bit selling company, as you understand. And you see the jet of the bit, they're facing down, right? Yeah. When I was young, 24th of January 2012, I was invited for a second round interview with Baker Hughes because they were giving me money, you know. I was getting a scholarship every year from Baker Hughes when I was undergrad. And they gave me an interview, and the interview was, I think it was a Nigerian guy, and he was working on that, and he liked football. And in the interview, we were talking about football, and he selected me for the second round. And I went, second round was in Houston, and they invited me for, I was like, they were like, Houston is within 200 miles from Austin, so we cannot buy you a flight ticket. You need to drive over. I was like, I don't have a car. Thank you very much. I'm not gonna come. And I was like, anyway, we went back and forth, back and forth. The last minute, they bought me a ticket to go for the interview. They were calling me. I was in class, you know. I was like, I got out of the class. I had like 1 million missed calls, and then I had to find somebody to drive me to the airport. Anyway, I made it to
The interview.
the interview. I was the only petroleum engineer there. Everybody else was like, it was like PhD students in computer science, mechanical engineering stuff. And anyway, they arranged us in groups, and we had to work together. It was like an interdisciplinary group, and we had to work in a design of a bit or a rig that was used for designing bits. And there was a guy in my group, I think he was in civil engineering. He insisted on having the jets facing the other way.
Not down, but
Yeah, facing up. And I was like, no, they have to be facing down.
So how do you guys resolve it? Because I want to see how teamwork you guys can work on with them.
Yeah, I mean,
So how do you resolve it?
I didn't get a job, so I guess it didn't work out very well.
Wow, they
Yeah.
didn't pick you ahead of over computer science and.
No, I mean, it was different. I mean, it was a nice experience.
Yeah.
I think for internship back then it was a 1-day event. For full time, it was a 2-day event. Yeah, and but yeah, it was. I think it was my first trip that was paid for by somebody else.
Yeah. Your process is vigorous. Like a huge process is very vigorous.
Yeah, I don't know Schlumberger what they do.
Same thing, same process, all of them adopt.
Yeah,
They have the same process.
Yeah.
They have like 3 rounds of interview.
yeah, it was.
What about the interview they used to invite people to and what's the name of it? PTRE, is it no? And IV, whereby you record, they recorded.
Oh, that's Shell, I think. That's
No,
a.
Baker Hughes used to-
Baker Hughes started this year.
Yeah, because they save money by. But back in my day, there wasn't. They were coming over. They were coming over to make an info session the day before they were interviewing, and you had to apply before you were interviewing, and they would tell you yes or no, and you go to the info session. But there was always a catch, and I don't think there is a problem saying that. They always leave some spots empty. So if they see somebody they like in the info session, they basically will ask you to come up for really. And I got some interviews like this. So basically, we'll dress up, go to the info session. There was free food, and then you will find the recruiters are there, and you will find the most serious looking recruiter and go most like logical that look logical to you, and go and talk to him, give him your resume, and you try to say something like, oh, look, I have scholarship from Baker Hughes, and then he will take your CV, circle it, and you look like, okay, I'm a Baker Hughes guy as well. So it's like, and then they call you at night, and you say, oh, interview tomorrow at 9 or 9:20. I found a slot for you, and you get another chance. You know, you get a chance. At least you get the interview experience. You know.
It's part of it. After it, you won't hear anything.
Yeah.
I've done a lot of the online interview. I've recorded videos. My
Yeah,
mouth is
it's,
almost.
Yeah.
I've recorded almost
And
7
then the
videos.
Keep trying, one day they will.
Every time you are getting, sorry, you have gotten a better.
And that's the one that there is a super major that says like if you do if you get a rejection, you cannot apply for the next 3 years or something.
Which company?
Which company is that?
I cannot say the name. but
Okay.
A super major that starts with S. The name, I think back in my day it was like this. You can't apply if you get rejected.
Uh-huh.
You can apply again
Oh,
for
okay,
2 more
okay.
years.
I think,
Wow,
yes,
that's
I know
serious.
about it. In Nigeria, they do it to 2 years.
Okay.
Really?
The same major, yes. You can apply until after 2 years.
Yeah, that was the system that they
But-
used back in
But
my
it's
day.
not fair, right?
Yeah, I mean, that's their system. That's their system.
Maybe I might change within a year. I might be now good.
So some other bits, more exotic looking, exist. Like the fishtail bit. This is for Louisiana. If you are drilling in diatomite, or well, diatomite is in California, but if you are drilling in a very, very muddy marshland or something, the fishtail bit was used. And since we are talking about Baker Hughes, I remember back in my interview, the guy that gave me the second round interview was talking to me about, it was the time they were designing this, which was the Chimera. It's like both. It combines roller cone and drag fit. And the reason for that is that we try to take advantages from both and eliminate disadvantages from both as much as you can. And I have heard that it was pretty successful in when you do thin sections and you go from hard to soft, you go from sections that are, you want this to sections that want this, but it's very, very thin layers. So it's good to use this. They had some success in Turkey, I heard, in sections like that. But everybody wanted to try it. Like they had a lot of success with operators wanting to try the Chimera. Because for us, I remember when I was mudlogging in a well, when they were tripping out of the hole and they were gonna go back in with a new bit, they wanted to consult us in deciding what bit to use. It was like they wanted to see cuttings. They wanted to see, even if it was the same kind of bit, because you know they buy, when you start the operator buys like maybe 3 bits that are next to each other, and they have a serial number that is just the last number different. You know, every bit has a serial number. There were differences between bit to bit, like even if it was the same kind, you know, and they wanted to make the best decisions before going back, before running back in the hole. So, any questions on bits? I have a book from 1960s in my office or at home. It talks about drilling with laser. So a lot of technologies that are like futuristic. they haven't had the development that people expected for the same reason that there are no flying cars today. There are no flying cars, but there are roadable aircraft. You know, there is no cars that grow wings and fly, but there are small aeroplanes that can fold their wings and drive them to your house, let's say, on the road. So the way technology advances is more down to earth, I guess. Anyway, what happens after drilling? After a drilling contractor has drilled a well to its total depth, the operator evaluates the drill formations and decides to either complete the drilled well, set the final string called production casing, plug and abandon the drilled well, P&A. And dry hole means that the well cannot produce enough oil and gas quantities. So it might be a dry hole that has oil, but it's not good enough, you know? And then in pad drilling, which is something that we do these days, multiple wells are drilled near one another. And basically, it's a comprehensive plan on how to develop that area, you know?
Is that one that the same as the infill, right? Drilling?
Infill is adding more wells into a field that is already developed. So infill wells is like we have wells here, 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 and I go and add a well there in the middle. That would be an infill well. But a pad drilling means that I'm gonna drill 4 wells here and 3 wells there with the same rig. I'm gonna drill the lateral where you are sitting, and then I will walk the rig for 12 hours, 10 feet this way, drill another well here, just the lateral, okay? And then another well here, and then I will switch to oil-based mud, go back into this well, drill the horizontal, then walk the rig back here, go back in, drill the horizontal, and then go back to where you are, drill the hole. Then I have 3 wells here, I have 4 wells there with a different rig. Drill about the same time. And I'm saying they are switching to oil-based mud because the laterals in the shale are drilled with oil-based mud. We're gonna see why. But the vertical part is drilled with water-based mud most of the time, which is cheaper.
So for after drilling, what will make you to after drilling you discover oil? What will make you to want to plug and abandon the well?
Well, maybe it wasn't as much as you expected. It wasn't the quality that you expected.
So you can say it's not in a commercial.
Yeah, not the commercial value. Yeah,
You need to.
maybe not the pressure that you wanted, or maybe you found more gas. You were expecting to find oil, and if you found gas, it's a little bit of a more complicated infrastructure-wise development, and maybe the price of oil and gas is not high enough for that. Casing. You know who invented casing? Yeah. I don't think he invented casing, actually. He didn't invent the casing, the steel tube. He invented cementing the tube in a well in place. You know who? Halliburton. Yeah. Earl Halliburton. Yeah.
Okay.
Yeah. In I don't remember what year. I saw the patent. People say he invented casing. It's wrong. And I remember I answered a question in Petro Bowl 2015 on the second round against Penn State. They said, name this individual who at the age of 18 or 19, he invented casing. And that's not correct. Because I read the patent. The patent is methods and means for cementing a casing into an oil well or something. It's not he didn't invent the steel tube, you know? But I got the point, you know? That was a very close game. Casing is a steel tube that starts from the surface going down to the bottom hole and is rigidly connected to the rock formation using a cement slurry, which also guarantees hydraulic insulation of the borehole. Basically, you protect your well with everything outside. And of course, you protect everything outside from what is in the well. So you have an aquifer here. You set the casing, you cement it in place, nothing from the well will go into the aquifer. And the other way around, nothing from the rock formation will go into the well when you case it and cement it in place properly. Now, the casing supports the borehole walls and prevents migration of fluids from the adjacent high pressure formation layers or to adjacent low pressure formations. That's exactly what I said. But I want to say something now that I remember. I have it later, but I want you to know. We talk about the difference between a derrick and a mast. I want to tell you the difference between a casing and a liner. Okay, you have here the liner, right?
Yes.
Liner is very simple. Yeah, no?
Yes, liner is, does not, you don't run liner to the surface.
Exactly, exactly. The difference, liner is just like a casing, but it doesn't go up to the surface. It ties somewhere down hole.
Yeah.
So know the difference between the two, but I think I have it in one of the slides that are upcoming. I just wanted to make sure I tell you that. Furthermore, the casing eliminates circulation losses, protects against borehole damages caused by friction with the drill string. You know, it's a smooth inside and acts as an anchor for the blowout preventers. In production wells, it also serves as the anchor for the wellhead called the Christmas tree. Something here that, you know, the wellhead, it has different name during drilling, during stimulation, during production, you know, on your wellhead. So during drilling, you have the blowout preventer on the top of the well. That's what you see on the surface. During production, you have the Christmas tree. During stimulation, the company would bring their own tree, it's called frac tree.
Yeah.
During cementing, the company brings its own tree, it's called the cementing head. Or cement tree. And that fits on top of the blowout preventers, actually. Casing dimensions, types of thread, and joints are standardized, API standards, with the functions and names of the various casings varying according to depth. So Halliburton has this book, I have it downstairs, it's called the Red Book, which has all the standards, all the casings, what is the outer diameter, what is the inner diameter, what are the thread type, all the information that you need. Back in my day, when we were doing homework, we had to use the Halliburton Red Book. And I think my drilling professor brought, Halliburton sent him as many Red Books as the students in class, and he gave them to us. And I have one in my office. Nowadays, there is an app that's free and has basically the Halliburton Red Book as an app. So if you are looking for a liner size, tubing size, everything, wall thickness, thread type, thread number, all the standards are in that Halliburton Red Book. And you might want to get used to it, using it. If you want to download the app, I think it's free. If I had came earlier today, I would have gone downstairs. I came straight to class. I would have brought my Halliburton Red Book. I have it in my office. I will bring it over next Tuesday if I remember. So Any questions about the casing? It's a steel tube, you run down hole, and what happens after you run it down hole? Yes.
So, if you're doing the casing, you drill, you do your casing, and what about if you drill a lateral, how the casing is?
Yeah, same.
So, like, by the casing, can it, let me say, bend to
Yeah.
that?
But it's gonna bend over a very big distance. So the bend is very small in each casing.
And then it will not have an impact on it as it bends.
Sorry?
Any impact on it?
Well, it's gonna happen, you start the turning in what we call the kickoff point.
Yes.
And you finish the turning in what we call the landing. They are very far away from each other. So the corner is very, very wide. The radius is very, very wide. The radius of curvature is very, very long, let's say. So it's very, very, the bend on each casing is very, very small. Very, very small. But in general, the casing is made of steel. It's metal. You can bend it to a certain level, or you can use some other material that is more easily easy to bend, I guess, to shape the direction that you like. So cementing, that's what happens after we run casing. And we spent a module on cementing in the previous class. There is a lot of process that goes through cementing, and some people are spending their careers doing cementing in the oil field. Cementing involves pumping a cement slurry between the casing and the rock formation by injecting into the annulus from inside the casing. And there is a big process and several equipment involved in that. And my old professor used to say, if you don't follow the procedure, it doesn't guarantee that you are going to fail, but it makes it easier for you to fail. So some things need to be done properly to lower the chance of failing, you know?
Preparing the cement slurry is one of the key.
The what?
I'm saying that how to formulate the cement slurry.
Yeah.
The required formation area that you drilled is one of the key.
Yeah, the cement mixing. The primary cementing rigidly connects the casing to the formation, guaranteeing hydraulic insulation, of the borehole, preventing the fluid migration from high pressure layers or to low pressure layers. So primary cementing is basically what you think cementing is. Secondary cementing is to fix anything that went wrong in the primary cementing. Okay, remedial stuff. So here on the picture, we see some of the components that are needed, but there are several components that are necessary, like centralizers. When you run the casing, you have some things called centralizers that make sure it stays in the middle of the hole, doesn't touch the side. Because remember, the casing is thicker, wider than the drill pipe. It's easier to get it stuck. So you need to make sure it stays in the middle. The centralization of the casing is particularly important as the geometry of the well is seldom regular, but tortuous and with a variable diameter. All other cementing operations carried out after the primary operation, either to correct an earlier or not very effective cementing operations, or for other purposes to repair a damaged casing, setting cement plugs, squeeze operations, and so on, are called secondary cementing. Now, when you do a cement job, a company comes and does the cement job for you, the operator. You are the operator. A company came over and does the cement job. If the cement job wasn't good and you require something like a secondary cementing, It's not the cementing company's responsibility to say if the cement job was good or not. It's your responsibility, the operator. Do you know a time when this happened?
During.
Macondo?
Yeah.
Macondo?
Yeah.
Top of Mesa.
Schlumberger did the cement job, but it was VP's responsibility to assess the cement job and say that eventually it wasn't good. They should have done some secondary operation to fix it. But they didn't, and they ended up having trouble. Because I remember when that summer after, I was with Halliburton, and I remember we were eating there with some people from Halliburton, and they said, if it was Halliburton who did the cement job, and the government, the judge said that it was Halliburton's fault, it wouldn't have survived financially.
It wouldn't have.
It wouldn't have survived.
So some media is more, some media has more money than.
Yes, of course.
No, but it wasn't Schlumberger's fault either.
It was
BP's fault.
BP, because BP didn't assess the work. The operator have to assess the job.
But they too should bear some fines too. Not budget.
Well, I mean, then BP can sue Schlumberger if they think that they didn't do
Good.
what they were supposed to do. But the responsibility of ensuring that your well is properly cemented before moving on is to you. It's your well, right? The operator.
They fire the company man.
Huh?
They fire the company man.
Well, the company man, there were two company men. I think both are dead right now. If not,
And they still paying the fine because my lecturer then said they are still paying the fine as when they taught us and when was maybe 20.
no, they are both. I think at least one of them died. The one that the Malkovich character that he was playing, he died. I know he had a heart attack or something. And the oil, the guy that what's the name of that actor that was Kurt Russell was playing the head of the rig crew also died as well later on. I don't know about the other company man, but yeah. Well, and 11 people died on the rig as well. Anyway, life is short, I guess. Squeeze cementing performed for remedial cementing operation. You might have heard of the term bullheading. It's also used to basically squeeze cement through like small ruptures. And I guess let's call it off now, and we'll carry on Tuesday with cementing, more on cementing. And I will fix the slide and re-upload. But I don't think it's going to affect you. It's just one slide that I want to make an animation. Thank you very much. Have a nice rest of your day. Sorry I was late in class today. I will make it up to you. If you have any questions, email me. I have office hours on Tuesdays, but you don't have to wait until Tuesday. Just email me and I will respond. The tests are set on the March 20th, the midterm. Miss Corney told me that it's okay with those dates. I forgot to tell you guys. Thank you very much. Have a nice rest of your day.